The lecture video will be posted to later on today after class. I just have to, my computer has to process that, and then I need to upload it to YouTube, and then I'll post the link, and the video will be available for you to review after class in case you missed something or you just forgot something and you sort of want to revisit the discussion. Okay. One of the first things I want to do before we really jump into the material, though, is share with you my screen, because I was looking over, what was I looking over? I was looking over the textbook. It's a really useful resource for you guys. So at the very bottom of the orientation module, we have this link down here that says access to the ebook. Ebook for Larson's Algebra and Trigonometry. When you click on that, it should open up the ebook. I already have a tab open with that ebook here, or you'll have to click on another link to get to the ebook. But in any case, the ebook is really nicely organized. And I am open already to the prerequisite chapter. Well, maybe we'll go ahead and close this tab. We'll probably close this tab. Click on the ebook just so you can see how you would access it. And don't mind that grinding sound in the background. That is my rabbit. She is chewing on wood right now. So we'll go ahead and click on the ebook. It should bring us to the Cengage Learning. It'll say Mind Tap at the top. And these are the chapters of the ebook. This first section that we're going to be covering today is from the prerequisite chapter. And we're looking at prerequisite chapter, so chapter P, section 3, polynomials and special products. So you can get into the ebook. It's really nice. This is your overview of the chapter. You can click the next arrow to get to the material. And the material is really straightforward, and it's actually not too bad of a read. They have definitions for you. They have a worked example with little drop-down boxes where you can see what the answer to the worked example should be. They also have checkpoints just to check your understanding of the material. And they have lecture videos here as well that you can review in case, for whatever reason, maybe my discussion of the topic seems a little bit more confusing or convoluted. Now, I like to think that there's a reason for my madness. So if what I say is a little bit confusing, I implore you to sort of try to understand what I'm saying. But there's plenty of great supplement here. So if you need to go back and review this stuff in the textbook, it's here for you. They also have formulas that we'll get into. And towards the end of the section of the chapter, as we continue to click on through, they should have some example problems, some vocabulary, some example problems that you can work through in case you need more practice. Now that is in addition to the stuff that we have in the workbook, right? So if you are in Canvas, I'm going to go to our modules page. On the left-hand side, the navigation panel, the workbook here for College Algebra Pre-Cal track, I have it open right now to our section on polynomials. Again, this is the basic material that we're going to be covering. It's a really quick read, and then they have some example problems that we will be working out in class. So I'm going to be stealing some of these problems, and we're going to work them out together, and then I'll have, at some point, put you guys into breakout rooms, and then you'll work those problems as a group and discuss them, and then we'll come back to the main session. So that's how things go typically in class. So I'm going to go ahead and stop the share really quickly, and we'll start our real discussion like 15 minutes after I said we were going to start. Here we go. Can you guys see my pen and paper over here?
Yes.
Cool.
Yeah.
So this is section P3. And this is polynomials. And if for whatever reason you can't see it clearly, I can always refocus the camera, zoom in or zoom out. So if I am zoomed too far in and you can't read it, just bring it to my attention that I need to zoom out. Okay. So can anybody tell me, does anybody know what a polynomial is?
A polynomial is a way to add or subtract real numbers in like terms.
Yeah. So you're saying a lot of things there that are good, right? Polynomials are these expressions that we come across in algebra that they have terms that are being added and subtracted together, but really sometimes they have what we call not like terms where you can't combine them. So for instance, let me just give you my definition of what a polynomial is. A polynomial is a type of algebraic expression that combines numbers that we call constants, variables, which is basically unknown values or placeholders, and arithmetic operations. So what do I mean by arithmetic operations? Well, that's your basic operations that you learn in grade school, right? Addition, subtraction, multiplication. And typically we don't see division in polynomials, but that is a possibility as well. Some examples of some polynomials would be like the number, I'm going to use the number 5. Even though this expression, just the number 5, is a single number, we can consider it a polynomial, but we can also just consider it a constant because there's nothing funny here. There's no missing value in this expression. We know what the number 5 is worth in a sense. However, if we had another example like 2x plus 5, this expression is what we typically think of as a polynomial, where you have 2 times some variable. So there's a number being multiplied by a variable where you have 2 of some quantity plus a known value, which is 5. Okay, so to sort of dissect the anatomy of this very simple polynomial, we need to think about what each of these numbers, what their role is playing, or what the term is and what role the numbers are playing. So this number in the very front of the variable is called a coefficient. And a coefficient is the number that's being multiplied by a variable. Okay. A variable is going to be a placeholder for some value that we don't know yet. We may be given the value at some future time, but right now we're saying, okay, we have 2 of something that we're going to call x. For instance, you might say we have 2 apples or some other kind of object that you might find at a grocery store, 2 oranges. So if this expression was telling me something about the cost of apples at the farmer's market, and I bought 2 apples plus something that I know costs $5, then that might be what this expression would be describing, right? I just don't know what the price of the apples is. Maybe I picked them up and they didn't have a tag on or a sticker. So we would write down, well, I know that this is going to come out to 2 times whatever the cost of the apples is. So that's what I mean by variables are a placeholder. So x is the placeholder for some unknown value. The number in front of the variable is, again, the coefficient. The number that is known and is not attached or multiplied by a variable, we call those constants because we know that they are a fixed known value. They do not change. and what do I mean by that? Well, the variable can change depending on the circumstances. I could go to some farmer's market and get an apple that costs $2 per apple, in which case I could say X is equal to 2 at one market. And then I can figure out the cost of, the apple and then whatever the thing is that costs $5. So 2 times 2 is 4 plus 5 would be 9. And I guess farmers markets are notoriously expensive because you have to pay for the quality of the stuff. Say that I go to a different market, and in that market, maybe it's only $1.50 for the apple. So in that case, 2 times 150 would be the 3 plus 5, and that would be 8, right? So I can evaluate these polynomials if I'm given the value of the variables. But for now, we don't have to talk about the variables as having some concrete value, and we can still manipulate and work with the variables in these polynomial expressions. They work just like numbers. We might have more complicated examples of polynomials. For instance, we could have 3x to the 4th minus 7x to the 2nd plus 2x plus 4. And you can sort of think about it as a slightly more complicated equation or expression that describes some other process in the real world. So now we have multiplication, we have subtraction, we have exponentiation, and addition. So when you're looking at a polynomial like this, you'll want to be able to look at it and then sort of count up how many terms there are. And what I will tell you is that terms are separated by addition and subtraction. So can anybody tell me how many terms are in this polynomial?
There's 4 terms.
Yeah, that's absolutely correct. There's 4 terms. So you should be looking at these expressions and saying, okay, there's a term there, there's a term there, there's another term there, and there's another term there. And I'm just using different shapes to sort of differentiate what the terms are. Notice that when I circled these things and boxed them in, that I boxed in the operation in front of the term, because you can look at polynomials in 2 ways. You can think of it as 3x to the 4th power minus this term, or you could think about it as 3x to the 4th power plus a negative 7x to the 2nd power. Okay. So either way, those are equivalent interpretations of polynomial, but yes, we understand that since we're thinking of terms as separated by addition and subtraction, that this polynomial has 4 terms. Okay. So in the textbook, you will see definitions of a polynomial that says something like this. So here's a definition.
Is it okay if I take a quick picture of that?
I'm going to put these to Canvas later.
Okay,
So
thank you.
when I post them to Canvas, I'm going to upload the lecture video, and then there will be like a little link where you can get access to these scratch notes. But definitely you should be trying your best to take notes as we're going along. So getting back to the matter, the definition that you'll see in the textbook about polynomials is that, and typically this is how mathematics definitions go. It'll say, let a to the n, sorry, a to the a sub 1, a sub 2, a sub 3, and so on, all a sub n, be real numbers where n is an integer. A polynomial is an expression written in the form And then they will do something crazy like this. A sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus ... and then a to the 1 times x to the 1, but we don't have to show the 1, plus a to the o. So if you think about this as a polynomial, each of these guys is a term. And what this formulation is trying to show you is that there are n terms, and this n, even though we don't have a number for it yet, and that's going to be the highest exponent on any of the variables, because we're sort of counting down as we go through these terms. Let's say that n is the number 10, right? So that means that this is a sub 10, or the 10th coefficient, right? So this would be a coefficient. A sub 10 times x to the 10. And then when we get to the next term, this would be like a counter that says, okay, what is 10 minus 1? Well, this needs to be a sub 9 then, x to the 9th power. So we went from the 10th power to the 9th power. And then we're going to count in that same pattern all the way until we get to, a sub 8 times x to the 8th power, a sub 7 times x to the 7th power, and so on and so forth until we get down to 1. So a sub 1 times x to the 1 power, and you don't have to show the 1 power, plus a sub 0, and then x to the 0 power is 1. So we don't have to, when you multiply 1 by anything, you just get whatever you had here. So that might seem a little bit confusing, but that's the way you'll see things written out in the book. I can explain that a little bit later if you need help with that. But really, we're just needing to be able to pick out the terms, pick out the coefficient, and then we have a little bit more vocabulary when it comes to polynomials. N, or the highest exponent on a variable, is called the degree of the polynomial. The term with the highest exponent is called the leading term. And when we get to graphing and stuff like that, graphing polynomials, this will make sense that the leading term sort of leads the behavior or controls the behavior of the graph of the polynomial. And we also call the coefficient that's attached to the leading term the leading coefficient. So if I were to give you a polynomial, we should be able to determine its degree, what is the leading term, and what is the leading coefficient. So if I had something like 4x to the 7th plus 8x to the 13th minus 10x plus 54, just sort of randomly threw those numbers together, those terms together. Can anybody tell me what is the degree of this polynomial?
Is it 13?
Yeah, it's 13. So that's how you can identify where the leading term is, right? Even though I didn't put the leading term in the front, I sort of put this out of order. This has to be the leading term because it has the highest exponent. This polynomial has to be of degree 13 because that's what the highest exponent is. And the leading coefficient is the number that's in front of the leading term, which is the 8. So we say that the polynomial is written in standard form if it is written in the correct order, and that order for this example would be where the exponents are in descending order. So if, for example, I gave you 4x to the 7th plus 8x to the 13th minus 10x plus 54, then to write this in what we call standard form, we need to put those exponents in descending order. So I would start with my first term being 8x to the 13th. The next highest exponent would be this term, which is 4x to the 7th. So I'm going to put plus 4x to the 7th because this is a positive term. There's not a negative sign in front of it. So I can just say that I'm adding it. And then next will come minus 10 to the x, and then plus 54. And that would be written in standard form now. Okay, does anybody have any questions so far? Okay, well, some more vocabulary here. We call a monomial, or we call a polynomial with only one term, a monomial. So some examples of that would be like the number 5 that we looked at earlier. Technically, this is a polynomial of degree 0 because there are no variables. We might have something like 2x, that's a monomial, or even let's say 3z. These are all monomials. Or even 1/4, let's call this p. Okay, so the coefficient could be a fraction, it could be a decimal, it could be a negative number. But as long as you're working with only one term and the exponent is a non-negative integer, then we're dealing with a polynomial. A binomial has 2 terms. So something like 2x plus 5, I think we saw that one earlier. You could look at 3z plus p. That is sufficient as well. And then we might work with trinomials as well. Trinomials. And this, as you can imagine, has 3 terms. So I can give you an example of what we would call a quadratic trinomial. So that would be like x squared plus 2x plus 1. There are 3 terms here. Okay. So that's sort of all the definitions that we need so that we can start actually doing some problems where we're combining polynomials. We have maybe more than one polynomial that we want to add, subtract, multiply, or divide. So we'll jump into that now by starting with some addition. Now, addition and subtraction are very simple when we're talking about adding and subtracting polynomials. So I'll sort of gloss over it a little bit. We'll just have a few examples of it. Adding and subtracting polynomials. So if I asked you, okay, we have 3x plus 2, and we want to add that polynomial to 5x plus 7. Can anybody tell me what is the process that I would use here to add these 2 polynomials together?
Would you distribute?
Well, when you distribute, what would you do?
Find like terms.
I don't think that you would.
So if we're just basically adding and subtracting, and you sort of vaguely remember from maybe your previous math classes, this idea of distributing, you might think that we need to distribute because there's parentheses on both of these polynomials. And so the reason I wrote it this way is just to make it very clear that we're just adding. We are just adding. So we shouldn't be doing any sort of multiplication. And when we did use the distributive property in the past, and I'll discuss that a little bit in a bit, we had to multiply something and then add stuff together. Okay, I'll elaborate that when we get to multiplication, but we're not trying to multiply anything. We're just adding and subtracting these polynomials. So you really need to not get, don't let your head get in autopilot. You see parentheses and you think you need to be multiplying. If we're just adding, you are going to combine like terms. That's what we mean when we say combine like terms. If you've heard that phrase before, you're just adding up the common terms. So combine like terms to add polynomials. Okay, so that means that if I look at this polynomial and I'm going to add this to another polynomial, let's make it a concrete concept, right? Let's say I have 3 apples plus 2 bananas, and I want to add to my cart 5 more apples and 7 bananas. Well, then I can just take my apples and add them together. So how many apples should I have in total?
8.
Yeah, if I have 3 apples plus 5 apples, then this should combine to make 8 apples. And if I have 2 bananas and I'm adding 7 more bananas to that, how many total bananas should I have?
9 bananas.
9 bananas, right? And I know that it seems like a very sophomoric or juvenile example, but I think that it makes it very clear that you don't want to be like overthinking it or sort of tricking yourself into thinking that you need to be just doing something more complicated. You're just combining apples and bananas. You're adding apples and bananas. So when we add these 2 polynomials and we have one binomial here, again, I had 2 objects or 2 terms, apples, bananas is the analogy I'm using. Then we're adding another binomial with a cart that has apples and bananas as well. We combine like terms and then we're done. So when we add these 2 polynomials together, we should get 8x, and then we have plus 9. Does anybody have any questions about that? Okay. Another example might be something like, let's do 3x squared minus 9x plus 10. I'm going to add this to another polynomial, like 4x to the second minus 3x minus 7. Okay. So can anybody tell me what I should get when I add these 2 polynomials together?
A negative number?
Well, you may get a negative term for something, but you might get positive terms for other things. So,
Yes.
so if I combine my like terms, because that's what I need to do to add these polynomials, what do I get when I combine? Let's call this apples, bananas, and oranges now, right? I have 3 apples here and 4 apples here. So how many apples should I have?
It's
7.
7x squared.
Yeah, I should have 7 apples or 7x squared. So one thing you could do is use a different color or use a different shape to go ahead and distinguish that, okay, we had to combine these 2 circles together. We get 7x squared total. Does that make sense? We have 7 of these things that we're calling x squared. Notice that the exponent didn't change when we added, and that should make sense. Or maybe it doesn't right now, but it'll make sense in a second when we start multiplying stuff together. But when you add, the exponents don't change. You just combine like terms and you keep the same variable, same exponent. Then you might want to use a different shape to combine the next kind of object or the next kind of term. So we have negative 9x and a minus 3x. So let's say that I owed the store for whatever reason. We're in a barter system. I owe them 9 apples. And then I borrow 3 more apples. I'm sorry, these are bananas, right? I owe them 9 bananas. And then I borrow 3 bananas. So how much do I owe them?
12 bananas.
Yeah. And since I owe them 12 bananas, then that should be a negative term. So negative 12x. And that's the same thing as saying to yourself in your brain, negative 9 minus 3 is negative 12. Or if you need to think about it in terms of your bank account, if I had a balance of negative $9 in my bank account and I spent $3 on my debit card, then I owe the bank $12. Okay. And then finally, we have these constants that we have to add up. So I'm going to call them triangles. I'm sort of switching and jumping between analogies here. So I have 10 triangles here, and then I owe 7 triangles. So I can just subtract that, right? 10 minus 7, and I should get a positive 3. Does anybody have any questions about that? Okay, so when it comes to addition, we're just adding or combining like terms. Let's go ahead and do some examples where we subtract though. So maybe I have a polynomial like 5x minus 45, and I want to subtract from this binomial. So I have this binomial expression here, and I want to subtract another binomial. And maybe I want to subtract something maybe smaller and easier to deal with. Like that. You know, I'm going to make these both positive just so that the first example is really simple. So I have the polynomial or the binomial 5x plus 45, and I want to subtract from that polynomial 2x plus 3. Okay, can anybody tell me what they think we would do here that might be different from addition?
Do we, in this case, distribute the negatives or the negative sign, the subtraction sign into the parentheses? So
definitely you can think about it that way. We can distribute or sort of multiply a -1 by each of the terms here that we're subtracting. That's how I think about it. But another way of thinking about it is it might be a little bit more simple, right? We have this polynomial and we need to take away each of these terms, right? Because we're subtracting. We're subtracting these 2 terms. So if we are subtracting both of those terms, wouldn't it be just simpler if we wrote it as minus 2x, I'm taking away the 2x, and then I'm taking away the 3? So in essence, it's the same thing as distributing the negative sign. But I think in plain English, you can think about it as we're taking away each of those terms from the first polynomial. So I might rewrite the polynomial first, and I can drop the parentheses at this point, and I'm just taking away each of these. So now I can sort of combine like terms as we did with addition, and it's going to be the same deal, the same process. So I have 5x here, and I'm taking away 2 of these objects that we're calling x. So 5 apples, take away 2 apples. You should have 3 apples left over. We have 45 bananas. We're eating 3 of them or getting rid of 3 of them. So I should have what? 42. Notice that in all of these processes, I sort of glossed over this, but we're not combining these 2 terms together because they're not the same kind of object. I'm calling these apples, it has a variable on it, and I'm calling these bananas. I can't combine my apples and bananas. It doesn't make sense to say, I went to the store and got 3 apples, and I added 4 bananas to that, or 42 bananas to that. And so in total, I have 45 bananas. or I have 45 apples, or banana apples. You know what I'm saying? So you can't just combine them, the unlike terms. So since we cannot combine this any further, that's how we know we're done. Any questions about that one? I think that that's probably a simple example, maybe one more. So we might have something like negative 9 x to the second power plus 10. And I want to take this polynomial and I want to subtract 3x squared plus 2x minus 14. Okay, I'll give you guys about a minute or two to sort of work this one out on your own, and then we'll figure out, we'll talk about it together here in a moment. But try to subtract that. And if you've completed the subtraction, you can use the reactions in Zoom to throw a thumbs up, or just post a thumbs up emoji in the chat. Cool. Okay. Okay. So again, my process in solving a problem like this would just be to distribute the negative sign on this second polynomial, because we're just taking away everything in that second polynomial. And it's easy to say, okay, this is definitely going to be negative 3x squared, and this is going to be minus 2x. But when you take away a negative, what should we be doing?
Adding.
We should be adding. Right, and you can think about it like if somebody was taking away, let's say I owed $14 to the bank, or maybe I owed $14,000 to the Department of Education for student loans. If they forgave my loans, if they took away my debt, that's the same thing as them giving me money, right? So that's the same thing as addition. So I'm taking away a negative, that should be plus 14. I can just bring these two terms down just as they are. I'm not changing them at all. They don't get distributed. There's not a negative sign in front of them, so nothing gets distributed here. Now I can just combine like terms. So we'll go ahead and add up this and this, because we have the same term, same type of term, x squared. We have these constants here. And it looks like this guy is the odd guy out because that's a different kind of term. So I'm going to combine my circles. This should be a negative 12x squared. I'll combine my, well, there's nothing to combine with my x's, so negative 2x is going to remain. And then plus 10 plus 14, that should be plus 24. And that is the result of subtracting those two polynomials. Anybody get anything different or have any questions about that? This feels pretty straightforward. It's going to be a little bit slow at the beginning of the semester, but I promise you it will ramp up and get a lot more challenging at some point. So just be patient. Don't be too eager to get to that place. Okay. All right, now we're going to get into multiplying polynomials. And the first example of this would be multiplying two or more monomials. So can anybody tell me what, let's say we had 2x and we wanted to multiply that by 4x. What should this be?
8x,
Why 8x?
because you are multiplying the 2 and the 4, but the x stays the same.
You're close, but the x doesn't stay the same.
So is it going to be 8x squared?
8x squared.
It should be 8x squared. Can anybody explain why we should have a square though?
'Cause it-
There's two x's.
Because there's 2 x's. Yeah, but let's be a little bit more clear about that. So if we're multiplying polynomials, here's the in-depth look. When we multiply two numbers together, it doesn't matter what order we put those two numbers in, right? If we have 2 times 6, that's the same thing as 6 times 2. It's sort of, we don't think about it, but that is one of the properties of real numbers, that when you multiply them, order doesn't matter. And when you're multiplying a set of terms, let's say a set of 3 or 4 or more numbers, 2 times 3 times 4, that's the same thing as 2 times 4 times 3 or 4 times 3 times 2. Doesn't matter how we arrange it. If we're just multiplying, the order of that multiplication doesn't matter. But if I had 2 times 2, I could definitely, say that this is 4, or I can write that as 2 to the second power, write it as an exponent. Does that make sense? Or if I had 10 times 10 times 10, I could write that as 10 to the third power. So if I have at some point an x times an x, then that's the same thing if I wanted to write it in exponential form. That's the same thing as writing x to the second power. So when I look at multiplying these two monomials together, right, we have one monomial here and another monomial here. I said before that the monomial is a combination of a number being multiplied by some variable, 2 apples. And maybe with multiplication, the analog of apples doesn't make a whole lot of sense here. But I have 2 times the number of apples that I have. And then I have 4 times the number of apples that I have. And since I'm just multiplying everything together, that means that I really have 2 times x times 4 times x. And since the order of multiplication doesn't matter, why don't I just rewrite this as 2 times 4 times x times x? And then it'll be simpler to just say 2 times 4 are 2 numbers that I can multiply together. That's 8. And because I multiplied x times x and I can write that in exponential form, let's just write it as x squared. That'd be a lot simpler than writing 8xx. So 8x squared is now the term that we have. Does that make sense? So if I'm multiplying something together, like a number, let's say 7 times 7 times 7 times 7, there are 4 7s, I could condense that into 7 to the 4th power. So if I have x times x, that's x squared. X times x times x, that's x to the 3rd power, and so on. Okay. So when you multiply variables together, then those exponents can change. But when you add and subtract, you're not multiplying things together, so you shouldn't be changing the exponents on things. Okay. Does that make sense? Okay, I know that it's a mistake that some of you will make in the heat of the moment, because when your brain's on autopilot, you're just going to do it. You're either going to forget to write down that exponent, or you're going to accidentally raise the power of that variable. So just be very mindful of that when you're working through the problems. What operation am I doing? Am I simply adding terms, or am I multiplying terms? If I'm multiplying terms, does the exponent change? Okay. So let's let's talk about multiplying a monomial with ... a binomial. So let's say I had 3x and I wanted to multiply that by 5x plus 2. What should this multiplication come out to be? What should the result of the multiplication be?
Is that 15x squared plus 6x?
Yeah, that's great. So again, we're multiplying this monomial 3x times this binomial. And I like to be very clear about this. This monomial means that this polynomial has one term, and we're multiplying one term times something that has two terms. So you can think about it as if I have one term times two terms, I should have two terms because 1 times 2 is 2. But here is where we're going to use the distributive property, or we say, let's take this monomial, distribute it right here. We're going to multiply it right here as well. So this guy in the front of the parentheses gets multiplied to both of these things inside the parentheses. So 3x times 5x is 15x squared. 3x times 2 is 6x. Does anybody have any questions about that? Okay. Negative 10x squared times 2x squared plus 4x minus 3. Okay, so now I have a monomial that's being multiplied by a trinomial. What should the result of this multiplication be? Anybody want to venture a guess?
Would it be negative 20x to the fourth?
Yeah. So our first term will be, we're going to take this negative 10, distribute it to the first term. So multiply it by the first term. And we should get negative 20x to the fourth. We'll distribute it to each of the terms though. And then what should the second term be?
Negative 40x to the third
Yeah, negative 40x to the third. And then the final term?
plus 30x squared.
Cool. Yeah, that looks good to me. Is anybody confused on why the exponents changed here? How we got, we had a term that had x to the second, and then we ended up getting x to the fourth, x to the third. Does anybody have any questions about that? So just recall that when we multiply this x squared times this other x squared, this is really, we can call the first x squared x times x, right? And if we're multiplying that by another x squared, that's really x times x as well. So in total, we have x multiplied by itself 4 times. So that's how we get x to the fourth. And then also when we took the x squared out here and multiplied that by the x in here, you can break this down into x times x multiplied by an extra x. And that's how we got x to the third. Does that make sense? Okay. All right, well, it seems that you guys are pretty adept at this multiplying polynomials. So I'm going to give you some examples and then sort of step back and let you guys work them out. So let's multiply two binomials together. Let's see about multiplying 3x plus 5 and multiply that by negative 2x minus 4. I'm going to give you guys about 2 to 3 minutes to work that out. And let's see what we come up with. Looks like we already got some answers in the chat for this one. If you are done, you can throw the thumbs up emoji in the chat, or you can throw the thumbs up reaction on your Zoom panel. Cool, cool, cool. Seeing a lot of thumbs up. You guys are on top of it. Is anybody confused as to how to even start this? And admittedly, I haven't given any explanations for how to multiply binomials. You know, those of you that are multiplying these binomials out using whatever method, you're drawing on your past information, your past knowledge of this topic to do it, because I haven't explained how to do it at all. Okay, so for those of you that, you know, have never multiplied two binomials together, or it's been such a long time, you might have heard of a process called FOIL. And what this acronym means is that we're going to multiply the first terms together, the outer terms together, the inner terms together, and then the last terms together. So you can think of it as these two terms in the two binomials that we have, they are the first in their set of parentheses. So I would multiply these two together. So this one gets multiplied here. Then I would multiply the outer terms, which are the two terms on the outside. So if these two terms are on the outside, then I would take this term again, the 3x, and multiply it by this outer term over here, which is the negative 4. I'd get that result, write it down, and then I would do the inner terms, which are these two terms. Multiply those together. And then I would multiply the two last terms. So if this is our first polynomial, this is the last term. And if this is the second polynomial, that's the last term. So it's going to be the 4 times the 5 times the 4. But I think that FOIL, even though it's a helpful acronym for multiplying two binomials together, we can just think of this as the handshake method. If these are two people that walk into a party where they've never met anybody at that party, and they meet two people at the party again who they have never met, then each of these people needs to introduce themselves or shake hands with these new people. So 3x is going to shake hands with the negative 2x and with the negative 4x. The 5x needs to shake hands with the negative 2x and with the negative 4x. And then everything is covered. All the parties have been introduced. And I think that that's an easier sort of analogy for when we get larger polynomials. So if we do this, we should get 3x times negative 2x, which is negative 6x squared. 3x times negative 4 should be a negative 12x 5 times that is negative 10x. 5 times this is negative 20. Okay. Once we do that, we can look at our polynomial and we want to simplify it as best we can. And it looks like we have some like terms that we can combine. So these two terms that are in the middle are x's. So if we're talking about apples and I have negative 12 apples minus 10 apples, well, then I should just simplify that and call that negative 22 apples. So combine like terms here, negative 22x, and then bring everything else down. Nothing else is a like term, so we won't be able to combine it. And since we can't do anything else with this expression, we're going to say that's the end of our job. No need to process that any further. Does anybody have any questions?
Yeah, I didn't see how you got well, I mean, I saw it obviously, but I
Yeah.
didn't understand how got 12 and 10.
Okay, yeah. So for this one, I did 3x. No. 3x times negative 2x gave me the negative 6x squared, right? 3x times negative 4. What is 3 times 4? 12. So I
Yeah.
did 3x times negative 4x to get the negative 12x.
Okay. Oh, okay. I see.
And then I did the 5 times the negative 2x to get the negative 10x. Yeah, it's a lot. It's a lot of keeping track of things. But we're going to have some more examples of this. So not to worry. And there will be plenty of practice in the homework. So let's do one more. Let's do x plus 3 times 5x minus 7. And in the interest of time, I'm going to work this one out along with you guys. If you need to do some scratch work, you can definitely do that. I just do a lot of it in my head. So again, we're going to multiply the x times the 5x. So if you need to put that scratch work here, x times 5x, that should be 5x squared. I'm going to write that down. Then the x times the negative 7 should be negative 7x. Then we need to get this 3, and it needs to shake hands with each of the terms. So 3 times 5x is 15x. So we have plus 15x. And then we have 3 times negative 7. And that should be negative 21. So minus 21. This is all my scratch work. Does that make sense? Notice that I had 2 binomials. I have 2 terms here and 2 terms here. And the result of that multiplication is a 4-term polynomial. Now, the only reason why this condenses down into a trinomial is because it turns out that of those 4 terms, 2 of them are like terms. And usually they're the ones in the middle. But that won't necessarily be the case all the time. But in our case, we can go ahead and combine the negative 7 and the 15x. And that should be what? Take away 5, that'll get us to 10. Take away 2 more, this will get us to 8. So that should be 8x, and that's positive 5x squared plus 8x minus 21, and that should be our answer. Is that what you guys got? Okay. Okay. Well, now we sort of want to multiply some more complex things. So let's multiply. And let me go ahead and give you some more challenging examples. I'll throw you guys in the breakout rooms and you guys can work on these for a second. Let's go with 4x squared minus 2 times 2x to the third plus 7x squared minus 5. let's go with 4x to the third minus 1 times x to the third minus 2x squared plus 5x. Let's go ahead and minus 10. And then 4x. I don't know why, I just keep looking at 4x. Plus 13 minus x squared plus 2x plus 1. And then I'll give you some challenging ones like x squared, 3x squared plus 5. And then I want you to square that. And then I want you to do 4x to the fourth power minus 7. I want you to cube that. Okay. So take a moment to write these down. What I'm going to do is open up some breakout rooms. And obviously this is math and you have to sort of work things out on your own for a moment. But once you get stuck or once you are finished in your breakout rooms, go ahead and discuss these problems with your classmates and see, you know, if you are stuck, if they can help you out along the way. I'll jump into the different breakout rooms and check on you guys and answer any questions that you might have. And then we'll bring it back to the main session in about 5 to 10 minutes. Okay, so I'm going to go ahead and open up those breakout rooms now. And there are almost 20 of us, so I'm going to break us into 3 groups. And I will go ahead and accept the invitation to the breakout rooms once you have written all of these problems down. Resume recording. Okay, so we're working on this first polynomial that I gave you guys to multiply out. We need to multiply 4x squared minus 2, and we're multiplying that by 2x to the third plus 7x squared minus 5. Okay, so in my head, what I would do is all of the multiplication with the first term in this first polynomial. So I would take 4x squared, multiply it here, here, and here. And this is where like FOIL sort of breaks down, because if you were trying to do first, outer, inner, last, you would miss this term here. So the handshake method, I think, is a lot better. This guy needs to shake 3 hands, and then this guy needs to shake 3 hands. So in total, we should be getting 6 terms, since I have 2 terms here and 3 terms here. 2 times 3 is 6. That makes sense. So I should have 4x squared times 2x to the third. So 4 times 2 is 8. We have x, and then that's to the second power to the third power. So I'm going to add those exponents. You can think about it that way. Then 4 times 7 is going to be 28, right? So that's 28. X to the second, x to the second. So that's going to be x to the fourth. 4x squared times -5 should be -20x squared. Okay, so that's the first round of multiplication. Then I'm going to take the second term in that first polynomial, and it is going to shake hands with everybody in the trinomial. And what I like to do is line up, when I multiply these out, I'm going to line up the like terms so that I can just add down these columns. So what I mean by that is I'm going to take -2 times 2x to the third. And so that's going to be -4x to the third. I don't seem to have an x to the third column here. So I'm going to have to make a new column. I'm going to put this as -2, sorry, -4, because I multiplied those x to the third. Then I will have an x squared here, so -14 x squared. And then I have a +10. I don't have a constants column. So when I add up my like terms, it looks like I just have 8x to the 5th plus 28x to the 4th minus 34x squared minus 4x to the 3rd plus 10. And all of these are not like terms, they're different terms. So I should be done here. This is my resulting polynomial. That's the product of multiplying those two polynomials. Is that what you guys got? I've been known to make mistakes.
Yeah,
Let's see.
that looks about right.
Yeah, mine's a little flipped around though.
Yeah, I mean, if you have things in a different order, that's fine, as long as you have each of these terms. Now remember, for this to be in standard form, you have to have the exponents going down in descending order. So x to the 5th, x to the 4th. Ah, there's where I messed up. I'm not in standard form. So I should have put the -4 x to the 3rd first. But again, since we're just adding and subtracting, the order doesn't really matter here. So if you have these flipped around, that's perfectly fine. Okay, what is the other example that we have? We have 4x to the 3rd minus 1 times x to the 3rd minus 2x squared plus 5x minus 10. So you might get pretty adept at multiplying these out. I like to put my fingers down to make sure that I know what I'm multiplying. But what I would first get here is 4x to the 6th. Again, you're adding those exponents, you're not multiplying them, because I have x times x times x times x times x times x. There are 6 x's. There are not 9 x's. So just be careful with that. And then we have 4x to the 3rd times this guy. That's going to be -8x to the 5th. Then we should have +20x to the 4th minus 40x to the 3rd. Okay, that's the first round of multiplication. 6, 5, 4, 3. Good, that's in order. Then I'm going to just multiply the -1 by each of these guys. And that's really nice because I will just put -x to the 3rd here, +2x squared, -5x, +10. So when I add all that stuff up, it doesn't look like there's a whole lot of like terms to combine. So we should have 4x to the 6th minus 8x to the 5th plus 20x to the 4th minus, that should be 41x to the 3rd. Remember, if I have -40 apples and I owe another apple, that is a total of -41 apples, plus 2x squared minus 5x plus 10. Is this what you guys got? Or did anybody get something different? Maybe I made a mistake.
No, that looks right.
Okay,
That's what I got.
cool. The third problem that I gave you was a trick. And if you guys were on autopilot and you were doing multiplication, then you would have messed this one up. But if you had noticed that this is a subtraction problem and not multiplication, then we have a different process for simplifying this polynomial. Then what we're going to do is distribute the negative sign and then combine like terms. So we should have -x squared, -2x minus 1 here, 4x to the 5th plus 3. Going to combine like terms. The only like terms I see are these constants. So we should have 4x to the 5th minus x squared minus 2x, and then we have plus 2. Did I trick anybody with that one? Did I slip you guys, catch y'all slipping? Anybody try to multiply them, be honest.
Yeah, I tried.
Yeah. And that's the thing, man. You have to be very careful about what you're looking at. Don't just be on autopilot. Be very mindful about what you're looking at. Okay. Let's do the other two. So this one was 3x squared plus 5. And then I squared that. Can anybody tell me how you would start a problem like this one off?
You can make it 2 binomials.
Yeah,
Okay.
exactly. That's exactly what I want you guys to do. So if you see a something raised to a power, then that means that you have that many copies of whatever the object is. If it's a number and we had 2 to the second power, you would write 2 times 2. So if you have a polynomial raised to the second power, you'll have that polynomial times itself, a polynomial times a polynomial. So we should have 3x squared plus 5 times 3x squared plus 5. 2 terms here, 2 terms here. I should be getting 4 terms when I run through the multiplication. So I should be getting 9x to the 4th plus 15x squared. We get another 15x squared from doing this multiplication, and then we get plus 25. We can combine our like terms so that we have plus 30x squared in the middle, since those are like terms, plus 25, and then we're done. Anybody have any questions about that one? Okay. Raising something to the third power is similar. But it is a little bit more of a pain in the butt. So again, we can write this as something multiplied by itself 2 times, or I'm sorry, 3 times, right? We have 4x to the 4th minus 7 times 4x to the 4th minus 7 times 4x to the 4th minus 7. So 3 copies of that polynomial. So in this case, what we're going to do is multiply 2 of the polynomials together. We'll get that result, and then we will multiply it by the remaining polynomial, right? It's the same thing as if we had 3 numbers. We would just take them 2 numbers at a time and multiply them. So if I multiply these 2 polynomials out first, then I should be getting 4 times 4 is 16, right? So that's 16x to the 8th minus 28x to the 4th minus another 28x to the 4th plus a 49. And I'm just working with these first. I'm going to drag this one down later. Let's combine like terms. 16x to the 8th minus, this should be, that'll be 40 and then a 16. So that should be 56 x to the 4th plus 49. So now I have this polynomial. This trinomial is the result of the first round of multiplication, but I still need to multiply that by the remaining polynomial up here. So this is 4x to the 4th minus 7. And with the distributive property, it doesn't matter if we do that handshaking method with each of these terms, where I drag the 16x to the 8th and multiply it by each of these terms, and then do the same thing here, and then once again. Okay, you just need to make sure everything gets multiplied with each other at most 1 time. Okay, what I would do is just take this polynomial, which has 2 terms, and then handshake in the opposite direction. Okay, the same distributive property, it's like multiplying. It doesn't matter if we multiply this guy by this guy, or this guy by this guy. Order doesn't matter here. So I will first take the 4x to the 4th and multiply it by each of these terms. 4 times 16, I'm pretty sure is 64. So this should be 64 x to the, we add these exponents, 12. This times this. Well, that requires a calculator because ain't nobody got time to multiply 4 times 56. So 56 times 4 is 224. And that's a negative 224. That is x to the 8th. And then 4 times 49 is plus 196, x to the 4th. Then I can multiply the -7 now by each of these terms. So -7 times 16, I should get -112 x to the 8th, -112 x to the 8th, -7 times -56. That is 392 x to the 4th. So we should have positive 392 x to the 4th. And then 7 times 49 should be 300 and something or another. 49 times 7, 343. So -343. Go ahead and combine like terms. 64x to the 12. Nobody knows what this is. It eludes scientific explanation. Minus 336x to the 8th. 196 plus 392 is positive 588 x to the 4th minus 343. Anybody get something different? It's very possible that I made a mistake while trying to rush and
Yeah.
calculate that. We got something different.
I got 32 x to the 8th minus 112 x to the 4th plus 98. But I didn't do it the way you did it. I did it the way I just kept on distributing the first term with the rest of them, and it just kept on repeating itself, and then I combined line terms.
Oh, I see what you're saying. So you like multiplied this 4x to the 4th
And with the rest of them.
with the rest of them.
Yeah.
Yeah, you got to be careful about that. It's the analog with numbers, I could say, is like if we had 2 times 3 times 4, is that you must complete this multiplication first, and then you take the result and multiply it by whatever you have left.
Oh, okay.
That's what we're doing here. So we're going to complete the multiplication with the first 2 polynomials, run through that process, and then take that result and multiply it by the remaining polynomial. I've seen where students will just start drawing arrows all willy-nilly. It's not going to end well for you. So just go through this process. Take it 1 at a time or 2 at a time.
Okay, thank you.
I have a question.
Yeah,
It's for a previous problem, if that's okay.
sure. Yeah.
So on the problem with multiplying the binomial, I used a rule that I learned. I don't know if it still applies, but it's where you multiply your 2 binomial numbers and then the exponent to give you your middle number as a simpler way. of
Oh,
solving.
yeah. So that's what's called a special products formula. So what he's talking about for everybody else's concern is that if you have, these are what are called special products. You might have heard this called perfect square binomials, and it's a formula where if I have, let's say, u plus v, and I square that what you'll end up getting is a u squared, a v squared, and then in the middle you'll get 2 times u times v. Okay, so if I were to put that in action, this is the formula that we're using. Let's look at that second to last problem, right? 3x squared plus 5 squared. Well, in this case, this first term is taking the place of u. The second term is going to be taking the place of v. And I'm squaring that. We have u plus v here. So if I follow this formula, that means that I should have u squared, which in this case, u is something different. It's 3x squared. So 3x squared. I should have plus 2, and then I should have u times v, which is going to be 3x squared and 5. And then I should be adding v squared, which is 5 squared. So if you were using this formula from previous knowledge, that's perfectly fine. It's a valid formula. 3x squared would be 9x to the 4th. When we multiply all of these terms out, we would get 10, 30. So that would be 30x squared. And then this would be plus 25. So if we take a look at what we did there, exact same thing. Okay.
And that's specific to that binomial, right?
It's specific to any binomial squared,
Right.
right? So if you have a binomial and you've squared it, then you could use this formula. But I think that the general handshaking process and understanding to write 2 copies of the polynomial is really important. Students forget that all the time. What you don't want to do is you want to make sure that if you have this binomial squared, you should be getting a trinomial. Do not do this. Students do this all the time. They say 3x squared plus 5. If I'm squaring that, let me just square both of the terms and I'll get 9x to the 4th plus 25. And it turns out that that is just not true. This does not work out, because if you were to run through our definition of exponents and run through the multiplication using that handshaking method that I showed you guys, you should be ending up with a middle term. This is missing the middle term.
Kind of how I started it. Then I was like, oh, it feels like something's wrong.
Yeah. So if you are missing a term, you've made that mistake. And again, students do it all the time. They just want to sort of distribute this exponent, but exponents don't distribute across addition like that. So you have to be very careful. Another kind of special product, I like to call it the difference of squares, but the textbook refers to it as the sum and difference of the same terms. So I call it the difference of squares. And that is if you have u plus v, and you're multiplying this binomial by the same terms, but now we have a sum, we're adding these 2 terms in this polynomial, and we're going to take those same terms, but in this polynomial, they're subtracted. In this case, what we should end up with is u squared minus v squared. Okay, so let's look at that example. So in an example, we might have something like x plus 3 times those same terms, so x and 3, but in the second polynomial, we're subtracting. If we were to run through the handshaking method for this, you would see that we have x times x, which is x squared, x times -3, which is -3x, 3 times x, which is a positive 3x, and then 3 times -3, which is -9. When we go ahead and combine like terms, you notice you have -3x and a positive 3x. If we're combining like terms, you can think about it like apples. I have 3 apples, and then I ate 3 apples. So I shouldn't have any apples left over. In that sense, we mean when we say we're canceling these out, we're canceling because they subtract and go to 0. So all we are left with is x squared minus 9. And we could have just applied this formula if we had if we had known about the formula beforehand. But again, it's more general. It'll be more useful if you forget the formula just to run through that handshaking process. So in your head, if you were to see something like 4x minus 5 times 4x plus 5, and you remembered this formula, you could say, I'm just going to square the first term, square the second term, and there should be a difference of those squares as a result. So this will be 16x squared minus, that's my difference, and then 25, since that is 5 squared. And that's using or applying the formula. Oops. Okay. Well, I was hoping to get into factoring polynomials here, but I did want to do a really thorough examination of running these operations with polynomials. Next time, which I think is next week, right? Next Monday. Actually, next Wednesday, right? Because no. We have class next Monday. Labor Day is later. So I will see you guys next Monday. We're going to be getting into section P4, which is going to be on factoring polynomials, which is sort of related to multiplying and dividing polynomials. And there are 3 main techniques of factoring polynomials that we're going to take a look at. But right now, what you should be focused on is section P3, which we covered today. And I'm going to go ahead and stop the share. So there will just be that one homework assignment in WebAssign that you will be able to access. Let's see if I can, show you guys on Canvas where it is. We're over here. And it's slowly loading. Maybe not. Okay. So in order to access the homework, I will throw things into module 1. That is where we are working now, right? We've completed the orientation module. If you ever have any questions about the class that you want to put out to your classmates or myself, you can join into the discussion board here. But homework 1, you will just click on this link. It should open up another page that takes you click on another link and it'll take you to the Cengage homework assignment. So let's see, once this loads, you'll click on this link to load homework 1, and hopefully, if everything goes well, it will load the content. If you have problems accessing WebAssign, this homework assignment, Cengage has been having problems over the last day or two, and the instructors in the department are aware of the issues that students are having, so we're trying to figure out what the resolution to that is. But since we have covered section P3, this is the only homework that you have to do by the end of the week, just multiplying polynomials. Really, that's the only operation that we're concerned about, because as we go into factoring polynomials, that is going to be highly or very closely related. So
I'm sorry, you were cutting out for me. I think, well, at least for me, when you were talking about the problems, I guess, with Cengage. What was that again?
there are just some problems that Cengage is happening at the beginning of the semester. The homework platforms get flooded with students using them and instructors using them, so they tend to sort of be a little wonky. If you have problems in the Cengage WebAssign, shoot me a message and I'll see what I can do on my end. But a lot of times we just need to be patient about letting them resolve that. But there's only one homework assignment that will be due by Sunday.
Okay. Because I was just having problems getting into the textbook. But
Okay.
I don't know if that had anything to do with that.
Yeah, I mean, if you continue having those problems, shoot me a message and we'll try to resolve it as soon as possible.
Okay, thank you.
Joshua, you have a question?
Yeah, so I clicked on it and mine sends me straight to the textbook. And it tells me to enroll.
Oh,
like,
okay.
to buy it.
Yeah,
no.
that's what I'm getting to.
Okay, so that means that you have not completed the orientation module part. I know that we sort of rushed through it on Monday, but let me go back to the modules. So X that out. You should not have to pay for it. You've already paid for it. What you needed to have done on the first day of class is run through the orientation module.
Yeah, I can sign into Cengage. Like, I'm in here right now. It just didn't load.
Okay, but you should not be having to buy anything or
Okay.
purchase anything. If you did this correctly, you will click here to activate your Cengage Unlimited subscription. You should have done this getting started with WebAssign assignment, and that would have completed your orientation. And then you should have been able to successfully get into this homework 1 without any problems, without it saying that you need to buy anything. If you're still getting that message that it's asking you to buy something, shoot me a message as soon as possible, and I will get with the Cengage reps and see what the issue is and see if they can fix it.
Okay, it's pulling up now. I got it.
Okay, cool. Any other questions? I'm gonna stop sharing. I will post an announcement in Canvas after class here in a few moments that just sort of remind you what we covered today and what will be due Sunday. Okay, so just be patient in me putting that announcement out. I will also be uploading the video from today's lecture, as well as the notes that I sort of scratched right here. So you'll have access to that in case you missed anything. So with that being said, you guys are free to go. If you have any questions, you're more than welcome to chill out with me and ask questions once everybody has left. But I'll see you next time.